Hello everyone. So our lesson for today will now be about logarithms and logarithmic functions. Okay. So what are logarithms? Okay. You already have an idea of what inverse operations are. Like the opposite of addition is subtraction. Opposite of multiplication is division, right? So in our lesson on exponential functions, the opposite of exponents are basic what you call logarithms. Okay? So like say 2 to the x raised x is equal to 4. That is the same thing as x equals log of 4 to the base 2. So you'll understand what this is. Okay? And how is this equivalent to that? Okay? Going on to the next slide, we'll now define what a logarithm is. Okay, so this is from the textbook. So let b and y be positive real numbers with b not equal to 1. So the logarithm of y with base b is denoted by the log of y to the base b. Look at the arrow. And it's defined as follows. Log of y to the base b equals x if and only if b to the x equals y. So notice that this one is read as log base b of y. So you can just say log base b of y. Okay, this means that these two equations are equivalent. So which means you can switch equations because they mean the same thing. Okay, so the first one is the exponential form, and the second one is what you call the logarithmic form. Okay, so since these are equivalent, we can switch exponential to logarithmic or logarithmic to exponential. Let's have some examples. So here, logarithmic form, what's the exponential form? So again, log to the base 2 of 16 equals 4. This implies that 2 raised to the 2 raised to the 4 equals what? 16. The base raised to the value equals the ones next to the log. Okay? Like this one, log of 1 or log of base 4 of 1 equals 0 because it implies that 4 raised to the 0 equals 1. So I hope you see the arrows that I'm pointing at. Okay? So next one, log to the base 12 of 12 equals 1 because 12 raised to the 1, this base right here raised to the 1 equals what? 12. And the last one, log to the base 1/4 of 4 equals -1. Why? Because 1/4 raised to the -1 power equals 4. Okay? So you can do this also the other way around. Okay? So given the exponential form, you can give the logarithmic form. Since 5 squared equals 25, so since here the base is 5, so it's the logarithm to the base 5 of what? 25 equals the exponents. Always remember that the logarithm is always equal to the exponent. Okay? Next one. 10 to the -1 equals 0.1. So this means that the logarithmic form is the logarithm to the base 10, okay, of 0.1 equals -1. Okay, next one. 8 raised to the 2/3 equals 4. This means that the base is 8, so the logarithm to the base 8 of what? 4 equals what? 2/3. And the last one, 6 to the -3 equals 1 over 216, so which means the logarithm to the base 6 of 1 over 216 equals -3. So you can switch from any form that you want. So exponential to logarithmic or logarithmic to exponential. However, we have special logarithms, okay? So first one is what you call the logarithm of 1. So the logarithm of 1 to whatever base, as long as it's a 1, is always going to be 0. Because always, any number raised to the 0 power equals 1. Okay? And the second one is the logarithm of a number with the same base. So log of b to the same base. If these two are the same, is just going to be equal to 1 because b to the first power equals b. Okay? So how do you evaluate log expressions? Okay? So evaluate what is log to the base 4 of 64. Change them to exponential function. Let this be equal to x. Okay? And then if you let this equal to x, okay, change it to exponential function, which is 4 raised to the x equals what? 64. Okay? So what number multiplied how many times do you have to multiply 4 to come up with 64? And that gives you what? 3. That's one answer. Okay? Or 64 is 4 to the third. So which means both equations have the same base. You can equate exponents. Next one. Log to the base 5 of 2. Again, changes to x. It's going to be 5 raised to the x equals 0.2. Okay? And then you can say that it's negative 1. Okay? 1/5 is 0.2. Okay? Next, number 3. Log of 125 of the log to the base 1/5 equals 125. Changes to exponential. So 1/5 to the x equals 125. Change 1/5. It's going to be 5 to the negative x equals 125. Now, 25 is 5 times 5 times 5, so 3. So negative x equals to 3. Therefore, x equals negative 3. Okay? And then the last one, log to the base 36 of 6 is equal to, changes to exponential. Now 36 is 6 squared. Multiply exponents, remember this, 2 times x, so it's going to be 6 to the 2x. And then 6 is equal to 1, right? So it's 2x equals 1, therefore x equals 1/2. Okay? Types of logarithms. So basically we're going to be working on 2 types, okay? Because the same thing with exponential, you have the base is any number and the one base, that's e. So same thing here. We're going to be having a specific type of base. Okay, so which is the common logarithm, whose base is 10. So which means this one is, if the base is 10, log base 10 of x, you can just simply write it as log x. Okay, so automatic, if it's just log x without the number, it means the base is 10. And the next one is the logarithm, natural logarithm, whose base is e. Remember e? So the logarithm to the base e of x can be rewritten. You can rewrite this as ln of x. So it means if it's ln of x, the base is e. Okay? So inverse property. So if you have 2 functions, g, which is log b of x, log b of x, and then b to the x. Now, if you get the composite functions of each, you get the same thing as value. So this one, log of b of x to the base b, or b raised to the log b of x, as long as the bases are the same, it's just equal to ex. Okay? Always remember that. You're going to use that most of the time. Okay, like say use this one. 10 raised to the log of 4. Remember, if it's log 4, the base is 10, which is the same base as the 10 here. So it's just simply equal to 4. Okay? Remember, it's same base. Second, log to the base 5 of 25 raised to the x. Now I can change 25 as 5 squared. So here I can multiply 2 and x. That gives me log to the base 5 of 5 raised to the 2x. Since this one has the same number as the base, the answer is just 2x. Using those properties, okay? Next, finding inverse functions. So we already learned how to find inverse functions before. So we're going to use inverse functions in finding between log and exponential functions. Like say, for example, find the inverse of the following functions. So f of x equals 6 raised to the x. So again, change f of x to y. Okay, there's a step by step. I'm going to put it right here. And then switch x and y. So y becomes x and x becomes y. Now, solve for y. To solve for y, change it to logarithmic. So that's going to be what? Y equals log of 6 to the base 6 of what? X. Right? And then That's going to be your final answer. Okay? Another example. Y equals ln of x plus 3. Change it to the inverse. Okay? Again, first step, you can write it as the function as is. Okay? Then switch. Y becomes x and x becomes y. And then you're going to change it. So since this is ln, the base is what? E. Change it to exponential form. So it's e to the x equals y plus 3. And then you solve for y. Therefore, y equals e to the x minus 3. So that's going to be your final answer. Okay? So that ends our discussions for today.